Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by ingesting calibrated night data right away. Align timestamps and GPS so records match daytime equivalents. This avoids later drift. Once ingested, normalize resolution and color space so algorithms see consistent inputs. Make sure to extract metadata like exposure, ISO, and ambient illumination because you will use those to correct biases. Tag basic conditions: clear, rainy, static. Moving, so you can filter noisy samples before model training or image fusion. Begin with a focus subset to validate the pipeline. Next, transform night captures into usable daytime-like inputs. Perform radiometric correction and denoising to recover signal. You want consistent dynamic range. Then use histogram matching or learn style transfer to shift color balance toward daytime distributions, because models trained on daytime expect different contrast and hue. Augment by simulating sun angles, adding synthetic shadows, and varying illumination intensity so your model learns invariance. Once these transforms are validated on holdout images, finally, integrate the process night samples into your daytime pipeline and retrain or fine-tune models with balanced weighting so night-derived examples don't dominate. Validate using cross-time holdouts and both numeric metrics and visual checks to catch artifacts. Deploy incrementally. Run a /B tests or shadow mode, monitor for drift in key metrics, and set clear rollback thresholds. If results degrade, check for mismatched normalization or unhandled noise patterns. Revert to the last good model and reevaluate preprocessing.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.